So I was writing a couple of notes on while Greg is talking. So you really justified clearly how to move to V6, DNSSEC, and blockchain for both technologists, governments, and business community. This increases fundamentally security, privacy, while reducing complexity when exchanging value between two entities. It is a simple and elegant process which could be applied across wired, wireless, so in this case Wi-Fi, Bluetooth, near-field 5G, 6G networks. And it has also ties to IoT and zero-touch networks. I know there are some slight issues and challenges, but they can be quickly solved and tweaked. So it will be up to our community to follow your roadmap and make it happen. And I have support from a lot of IPv6 technologists reading your latest paper that will be published very soon at ETSI or at IEEE. I was supposed to introduce you, so C. Said and C. Isa have made an excellent presentation. You should know that you are talking to the, most probably to the world pioneer of blockchain. I know a lot of, because he's in a competitive environment. So when you are in business, you get more haters than supporters. But I know for sure that he is a world recognized and accepted by his followers, and there are millions of them, and that he is the pioneer of blockchain and Bitcoin, and now restoring it to BSV, AK and Satoshi Nakamoto, and I think we should recognize this, and I'm very pleased that we have him with us today. So I would like to compliment on what he has spoken about, because he's going to touch all the other technologies. So first of all, we really have not invented the web. It was invented millions of years ago by a small spider that saw flying food and said, how can I capture it? So he built, vertical nets from his own body. So it's an amazing achievement. So what we are doing now is we're just basically trying to do the same thing. So we are not doing any innovation. We're just copying, one of the fantastic things. So a couple of researchers have done following. So they took spider, and then they sprayed it with caffeine. And basically, this little thing has lost its engineering of his main tool, to feed itself. So if you are drinking any coffee in this room or during the day, you don't know what's happening to your brain. So watch it. But to match it with the internet, so basically they added marijuana to it, and that was the last. So some people are against it, although it has some benefits for a certain time. And as Greg mentioned, NAT, network address translation, which is basically cutting the communication between two end-to-end situations. So I have just dubbed it as marijuanat, okay? So this is currently what we have in the internet. So we're on some steroids on the internet because some of these, big servers are serving us. So the model of master and slave is still in the internet, unfortunately. So this is a colonial approach to the internet. And then some people said, yeah, we can also traverse basically the internet. So they have put some other things on it, and there are some protocol called STAND, to create this traversal of the nets, to give you, the impression that you are also peer-to-peer and end-to-end connectivity, which you can do with VPN and the likes, all right? So quick history of the internet. So basically, it was not easy to get the internet working. And it was also not something which has been systematically done. When Sputnik was launched back in '56, so Eisenhower was so upset that he said, we need to do a better job. So started the famous ARPA which created two things 10 years later. So it was the flights of the Apollo on the 17th of July, 69, and the internet on the 2nd of September, same year. Okay, so that was a real achievement. But then the address space was only 2 to the power of 8, so only 256 could be connected. And by 71, we ran out of ARPANET addresses, and Bob Kahn and Bintsurf designed TCP/IP at that time. You know, word processors didn't have enough memory, and everything was really primitive. So for a research project, they picked up 2 to the power of 32, which is 4.3 billion IP addresses, and that was at that time a massive address space, and nobody believed that such a thing is going to be, you know, worldwide success. This is the beauty of some researchers that have hit something that is, you know, world-changing, and they never believed that's going to be the case. And but despite that, the U.S. government itself, back in '85, decided to stop TCP/IP, and started OSI. Okay, so there was a government with some vendors that didn't want to have this end-to-end connectivity. And it took a lot of effort from Bob Kahn and Bintsurf to lobby the industry, you know, to basically move to TCP/IP. And that happened in '91 when they have basically lobbied Al Gore. And Al Gore mentioned in his, one of his speeches that he is the inventor of the internet. So he won with that thing, you know, the election. You know, I travel quite often to Washington, and I pick up always in this topic with the taxi drivers and tell them, you know, do you know who has invented the internet? And these guys are from Eritrea or Somalia. They say, yeah, it's Al Gore. So it's known in the US that it's the case. So you can create fake news. Fake news is nothing new. It has already existed with us. So, but on the back of that, the decision, the address space was already depleted by 50%. So the call to design the follow-up protocol started in '92, and then a number of proposals. So we had IPv6, V8, V7, and V9. And in the end, in '98, V6 was selected. And from there on, we started promoting it around the world. But it is really tough because the legacy is so huge, and in order to update everything, and you have to have a business case for it. So the first business case we could find is 3G. So that was in '99, where the 3G world, they wanted to use rather WAP, in this case based on IMS, which means that every ISP can invent his own internet, but totally disconnected from the internet at that time. So we could explain to them the use of IPv6, and that was the first killer application, which reminds me exactly that we are now going into the second largest killer application with blockchain. Okay, so take 20 years until you get to this one. So I was very pleased to meet Greg, and following up with Jimmy, and as well as Hank, that are going to really start something very great for the entire planet. But it's not going to be easy. So it took us 20 years to get V6 now at the current stage, because we still have some work to do. So if we look at the IoT, let me see. So the impact of the IoT is going to be very important. So here we have also another fake news with Kevin Ashton, who is just a marketing engineer at MIT. While presenting RFID to the press, and they asked him, what's the link between RFID and internet? He said, yeah, this is Internet of Things. While RFID is not connected to the internet at all until today. So we have some tests that are going to be done, but RFID are so small, they don't have even enough CPU and ASIC in order to add IPv6 to it. But it created a big thing, because after the Internet of Things is the biggest thing that we have today. So you can also create fake news for very large technologies, which is quite happening today. And currently we're running primarily IoT based on IPv4 and NAT, which is not really the purpose of IoT. It's with IPv6 where you have two-way IoT talking to each other, and then you can do blockchain on top of that. So that end-to-end, even if I can use the word peer-to-peer, because you have the peering at the top level, which is happening free of charge between the ISPs, but we don't have peer-to-peer at the end user level. So this is what we have to create. So doing peer-to-peer among people, among customers, and especially among the billions of devices that talk to each other. We don't have to intervene there. They can just talk to each other. Okay, this is fundamental. But all of this stuff is insecure. So we have to find a way to secure these things. And to be honest with you, the security expertise on this planet is not enough. Okay? Where they have not done for sure a good job for enterprise, but not for the end users. So possibly we are now starting something very big with blockchain. Then quick words about the moving from 1 billion of nodes or 1.5 billion that we have today into multi-billion nodes. So you need to have that single identity with the embedded privacy as well, which we have in IPv6. And you need to have auto-configuration, which is very important so that we don't need to configure these things. They are self-configured. And multicast is going to be very important because today we are using broadcast on the internet. That's very expensive, especially for wireless. You cannot use broadcast. It's like sending radio on this expensive spectrum. So multicast will be the solution down the road, and this is embedded in IPv6. So IPv6 is multicast-based right from the beginning. Then obviously the mobility has already proven its case, and we will have, at the same time, security and privacy working. As when you log on the internet, the application or the operating system uses the privacy IPv6 address directly to connect you to the websites, so nobody can trace where you are. But then at the same time, we have the online IPv6 address that's yours that you can use for application. And currently, I haven't seen many doing this. So with blockchain, it will be the first time that we are going to use the routable IPv6 address that each one has. So you always get to IPv6 addresses directly from the operating system. So the end-to-end model is really fundamental to create the biggest innovation that we have ahead of us. And all of them are going to happen based on the various devices that we are going to see in front of us. So currently, we have achieved 45% world penetration of IPv6. And Google is the only one that can tell us how many people are using IPv6. Nobody else can do that because they have the geolocation, which is fundamental for their finding their own customers around the world. But they don't have access to China, since China is run by Baidu exclusively. So they don't see the other almost 500 million V6 users in China. So if you put them together, you have about 2 billion from the 5 billion we have that are using IPv6 without knowing it, and that is a good thing as well. So when you have this kind of percentage, so you basically have the critical mass, to move into the next one, and you will see some of the things. So UAE is very well positioned. It's about 45% penetration, which is very good. This is due to the work has been done by Etisalat. So I expect DO to follow up, which is the next one. I think the efforts done by TRA are quite good, since we've been working with them for the last 20 years on this one. If you look at the websites, so you have a very good access in terms of websites. Only a company like Amazon does not yet support IPv6 because it's a cloud, and most of the clouds still today run with IPv4, which is a shame because they are going to block basically the enterprise and SMEs from IPv6 because they run it on IPv4. So we're doing everything now to get them on v6. And then basically, if we take this thing, so all of us are on net, so we're on the luggage class, so nobody is even on the economy class, all of us. And if you connect to the internet today, you have only IPv4, then you are really not, you're just a slave on the internet. You don't even exist, okay? And the current deployment of IPv6, you are directly on business class. And when we add new things on top, in this case, IPv6 only, and this is going to happen in the next 5 years, and then combined with the various technologies like 5G, cloud computing, IoT, and blockchain, based on blockchain, then you will be on first class. And this is really a fundamental move that we have to all to do and I'm glad to have the blockchain folks also working on this one. So our target is quite clear, first class for everyone. So in terms of web generations, it's quite interesting also. We have another fake news in between, which is Web 2.0. Tim O'Reilly just organized conferences when Facebook and Google started. So he invented this thing without any protocol, so it just pissed off Tim Berners-Lee, who started, in this case, with semantic web, which is the real Web 3.0. And in the meantime, Dave Rugged from the University of Bath has started the Web of Things. So if you are doing any research, you should look at that thing. And in the meantime, we have these guys called Web3, based out of Zurich, which is, as a matter of fact, blockchain-based Web3, so we should talk to them. And also the metaverse guys. You know, all of these guys do not have any standards behind them, but you're going to hear a lot from them. So there will be a lot of noise in this area. So we need to capture these guys, you know, to get them to do the right stuff with us. And in terms of wireless generations, so obviously in the meantime, we are on 4G and 5G. 4G is now driven with IPv6 primarily in the big, among the big operators, like the one in India, which has about 450 million IPv6 users using 4G. And within the house, it's IPv6 only. So this has shown that in order to get efficiency and highly managed networks, you do IPv6 in between. And the internet companies like Google and Facebook and so on are doing IPv6 in-house and servicing IPv4 users through their transition mechanisms. One of them is called XLAT. So 5G is looking at a certain number of verticals, so industry, Industry 4, and so on and so forth. And in the meantime, we have also the move to 6G. 6G has, unfortunately, the wrong spectrum, which is terahertz. Terahertz has very high speed, so gigabit, but the limitations are going to be distance, so you have only 10 meters of distance. And then it is not crossing walls and windows and so on. And it cannot be used outdoor, because when it rains or leaves are falling, it disrupts the communication. So probably 6G should not be based on speed, but primarily to look at how we can get satellite and Earth communication and see cables to all communicate in an interoperable way, not to be as silos. So most probably that's the way 6G should be defined. And a lot of research is done in this area. And then I think I have discussed the IoT side. Then we have the data generation. So these are data generations are stuck now in the big data, which is a static thing, so you have to analyze the data. So you want to move to instant data analysis with instant messages that come out, and this we'll see with big IoT data. So from IoT, you will get decision making instantly in order to see exactly what's happening in your enterprise or in your banking and so on and so forth. And we have done a lot of research in this area, and it's quite amazing how V6 is going to enable, in this case, big IoT data, which is far larger than big data today. And in terms of the cloud computing, so a lot of people think that Africa has never contributed. As a matter of fact, two guys from the University of Cape Town have invented what is called elastic IP, and they've been hired by Amazon, and it's these guys that have implemented AWS a while back. In the meantime, they have left. They have started their own companies and so on. And one of the issues with Amazon is a proprietary stack. So proprietary means that they can abide very easily to the Cloud Act in the US. So the Cloud Act entitles the US government, and especially NSA, because of the 9/11 and so on, so you have the Patriot Act on top of that. So they can read any data that has been produced here, but archived in the US. So the archiving has to be in your country. So this is where data sovereignty is a big issue. So you have to watch this, that your data is not archived back in the US. Okay? So the European Commission has been promoting what is called the Gaia X, to this connects from any cloud computing company in the US, and all the data is archived in Europe. So you should most probably follow that model as well. In terms of artificial intelligence, obviously nothing can beat the human intelligence, so thinking brains. And the ultimate thing is to get thinking machines. But they will still have to be programmable. In the meantime, we have just pattern-based thing, but it's a real progress in this area. But when you get to thinking machines, then in this case, we will be at the link where is human thinking better than still machine thinking. The only thing that's tough with artificial intelligence is still based on software. And software is not bug-free. So it has to be solidly tested to make sure that we don't have issues down the road. So I know Dr. Isa is very much into artificial intelligence. So promote secure IoT, AI, more than anything else. So that's the only way to get that. So if we can get some blockchain to be implemented in this area, I think that would be good. Yeah, I don't think I need to repeat what Greg has said. I have already surfed on his work and found in one place that he said, yeah, he wanted to review blockchain and Bitcoin as well as add IPv6. That was prompted me to contact him because I was the only one around the planet talking about blockchain that mentioned that line. So I have that little website which I use most of the time when I talk about it. This is more the Ethereum let's say, kind of stack. It's V4 based. So even if the data is encrypted, the network is hackable. So, remember back in July 2017, when the keys have been hacked, Bitcoin just dropped from 20K to 5K. So, we have to look into this as well. So, but, you have many things coming down the road, still not very clear. A lot of companies are in this area, smart contracts and IoT, blockchain. So how you look into these digital keys. Quickly, so basically, by 2025, you would expect that the US government will move to IPv6 only, 80% of the network, so the US government networks. So they have a mandate and a roadmap for this one. Unfortunately, not funded. That is the only problem. So they have to put some funding for this. Like the Chinese government, they put funding to rejuvenate their network and so on. So you have to depend a lot on the enterprise, but if the government is the biggest buyer in a country, they don't mandate these things, then basically the telcos and so on, they're not going to do anything because there's no money into it. So this is the issue with large-scale upgrades of the internet. But we expect the top 100, primarily 5G standalone, to do V6. And we have a couple of cases, especially in the US, a couple in Europe, and in India and China. And we would expect those that do 80% of the web, top 1,000 would be on V6, and in terms of enterprise, also top 1,000. And obviously, the peer-to-peer applications on blockchain is now going to be most probably the most used. Any application would be using blockchain in one way or another. So it would be up to us how to make it simple to use. So the complexity can frighten people. So we have to really make it easy to use, especially for the end users. So we have to suck the complexity away from the user and then putting it into the network. But still, we will have a new digital divide. So we expect 25% of the internet will be on IPv6 only, 50% doing dual stack, and unfortunately, another 25% would be on IPv4 or NAT. Okay, so this is the problem when you introduce new technologies. V6-based blockchain, or the other way around, is very good for the UAE. And the UAE, as an example, in this case, is very good for IPv6 and blockchain. So if you take leadership there, since you have a very good reputation in the Gulf states, and in the meantime, around the world, just see how many flights are coming to your place. They can pick up from you here the ideas. So that's why we focus to get this kickoff in your place to set the example, all right? And you have the support of Vincerf himself, who said in one of the conferences back in 2019 at GlobeCom in Hawaii, when somebody asked him, what would you have done if you knew about these problems back in the 70s? He said, yeah, we should do IPv6 right from the beginning. This is a very sign of intelligence and humility that somebody's, even, says that, they missed the point. And now I think we can rectify this. So let's learn from these people, through their humility and through their intelligence, that we follow their roadmaps. Thank you very much. I take the easy questions. Send the tough ones to Greg. A complex one? Easy? We need a mic. Do I give it? Because we are videotaping.
Since this IP version 6 became really practical and was put in use, why was not the IP version 6 designed so that it has flexible length instead of fixed length? So that would, I think, solve the problem in the very, very, very long way and make it usable for infinity.
The question is not very clear. So
yeah. IP version 6 has fixed length, right?
Yeah.
IP addresses like IP version 4.
Okay.
So now, was it possible to design it so that it has flexible length instead of fixed length?
No, I understand.
I know there are many technological challenges with that, but
no, there is an answer to that.
It's still doable, I think.
There is an answer to that. So basically, V6 design was a clean slate. So looking at V4 and how we can do it better. In order to get high speed on the processors, it's better to have fixed length. So if you make it flexible, then in this case, the processing at the routers will be too long. That was one. The second one is the address space had to be extended. So, and there was not enough in order to also make it compatible with IPv4. So the idea was, if we include IPv4 to make it compatible, we would never get rid of IPv4. So when we decide at the end to divorce the internet from IPv4, it's better not to put IPv4 in the stack right away. So you can run dual stacks. And when we quit V4, then we have a clean slate, new internet. Okay, so the flexibility is sometimes not very good for processing. Okay? That was not an easy question.
Thank you, Professor Ladid. My question is that where you think we are going after IPv6? Now we have IPv6, 128-bit. Will it have like 256 and then grow? Or you think that will be like lasting for 10, 20 years from now?
Yeah, so, there are some, so first of all, we have V6, V7, V8, V9. And V6, V7, 8, and 9 have been deprecated, which means you cannot use that. So the next possible version will be V10. We have only 3 possibilities, V10, 11, 12, 13, and 14. So there should be a call from the ITF in order to say, well, we have a problem with IPv6, we need to have a new version. Then a call has to be sent out, a lot of responses will come. And then the new specs will be defined, what should be the next one. This call will not happen that soon because the address space is there. If you go to 256, it will be really impossible to compute with the current thing unless you will move to quantum computing and so on and so forth. So the speed on the internet is not yet that high and the routers are not yet that, especially the routing tables can explode to 1 million. That's not very good, especially for developing countries that they have smaller routers. So their routers will be flapping quite easily. So you have to have kind of the, let's say, responsible definition of the protocol, so that you have a worldwide interoperable thing. Okay. So come back in 100 years, but you never know. So if Greg decides to find something new, then then he can throw away the whole thing. Which is most probably possible, you never know. He just finished a couple of has done a couple of PhDs even on religion and what have you, finance and so on. So we don't have that kind of technologies that have multiple approaches to finance and law and religion and so on. So you have a global view. That's why his kind of call for everyone on the same on the same plate, not the top guys making money and the other guys are just slaves. Huh? Okay. So which is very laudable, especially coming from an Australian. Huh? Yes, please.
Thank you so much again for the presentation. This is Claude from University of Dubai. I just wanted to know about, the time. It's been a while we're talking about IPv6. It's been more than 20 years, and we're still at 30%, 40% maybe achievement. So isn't it taking too much to achieve IPv6? And we're talking maybe about IPv10. Or so. Why do we need IPv10 if we cannot, integrate completely? That's the first part of the question. The second part is, how about the control? I believe that there's so much challenges today to manage and control the IPv6. Today we can scan IPv4 for within a few hours with open source tools, which are all available. How about IPv6? There's no capabilities today to manage all the IPv6 space. Yeah. Even top-notch companies like Google cannot even scan that.
Okay. So first one is, if we didn't have IPv6, the wireless internet revolution would not have existed, because we have proposed to ETSI and 3GPP back in '99 that they should embed IPv6, because they didn't want to have IPv4 because they knew there's not enough address space and so on. So they decided to use IPv6, and was also specified in one of the ETSI documents back in May 10th, 2000. When the deployment happened, most of the ISPs said, we don't have the knowledge, we have to train everyone. Then the vendors didn't have the product as working, so they retreated back to IPv4 after all. So if we didn't have IPv6, in this case, the wireless internet would not have existed. And it's later, Apple has introduced the iPhone in 2008. So IPv6 in this case already created something big. We're talking about the next big thing as well. And at the same time, you have $10 trillion legacy networks around the world. You cannot switch them off to IPv6. That's very tough, because every network is totally different. So you will not have one single best practice or practice guide to give each one how to do that. So they have to learn from each other. This is where interoperability is very good. And this kind of conferences are very important to share how successful this and that has been done. I shouldn't have mentioned IPv10. It was just a joke. It will not happen. I know the ITF. They are suffering to get IPv6 to be done. Like looking at CGA++ and so on and so forth. Many of these things are still there. So they are so happy that we have reached 45%, not 20%. That was 10 years ago. 45% is very important, because then the big guys are going to do that, and then there will be a ripple effect on the other guys. So it's very good news for all of us that this thing is happening. If you look at IPv4, it was even kicked out by the US government. This is not the case this time, because it's the US government which is promoting it. So IPv4 had harder time to get involved, to get deployed. IPv6, it's the internet industry itself that had hard time to do it. So don't expect another thing. You will be the most hated person on this planet. And I don't think I will have time for this. So. I know it's not a response, but that's the fact. Back to you, Saïsa. Said.
Assalamu alaikum. Here is the simple question that I have. Actually, is there anything related to the aeroplane safety and security issue with the 5G? This is what we heard lately.
Yeah. So I happen to be board member of 3GPP, and I was flying a couple of weeks ago from Frankfurt to Luxembourg, and I have a 5G. And I was in the plane. I didn't switch it off. up to 3 kilometers is still working. I'm here alive. So yeah, you will always have these news and so on. The same thing happened to 4G, and it will happen to 5G. But from our knowledge, it's the same spectrum. So if somebody from the airlines is using a spectrum which is at the edge of 5G spectrum, yeah, it could be that there are some communication, but these things can be tweaked. So one has to go lower and the other one has to go higher, you know, to leave. But right from the beginning, there is no intersection between the two. But, you know, the press and especially, you know, some activists are always there, you know, to disrupt these things, but I don't think it's an issue.